Your company has a dozen internal APIs. There are third-party services like GitHub, Jira, and Notion. Writing a dedicated MCP server for each one would take weeks. In this episode, we build a generic API wrapper server that reads a config file and creates MCP tools for any REST API automatically. Add a new API by adding a few lines to the config. No new server code required. The design has two layers. A config file defines every API and its tools. Each tool entry maps to one REST endpoint and describes the method, path, parameters, and authentication. The Python server reads this config at startup and dynamically registers the tools. When a tool call arrives, the dispatcher looks up the config entry for that tool name, builds the HTTP request, injects the auth headers from environment variables, and returns the response. No Python changes needed when you add a new API. The config file is YAML. Each API block has a base URL, the name and prefix of the auth header, and the environment variable that holds the token. Each tool entry has a name, a description for the model, the HTTP method, the endpoint path with parameter placeholders and curly braces, and a list of parameter names. The server reads this at startup and generates tool definitions and a dispatch table from these entries automatically. The call API function is the engine of the whole server. It receives the API config block, the tool config block, and the arguments from the model. It reads the token from the environment variable named in the config, builds the auth header with the correct prefix, and formats the endpoint path by substituting the argument values into the curly brace placeholders. This one function handles path parameters for any API, regardless of its URL structure. For GET requests, we pass no body. For POST, PUT, and PATCH, we separate path parameters from body parameters by filtering out any argument whose name appears in the params list. Everything else becomes the JSON body. We raise for status to catch API errors and return the raw response text. The model handles JSON or plain text responses equally well and can parse whichever the API returns. We build the tool map at module level by iterating every API and every tool in the config. The map stores the API config and tool config keyed by tool name. The list tools handler generates a tool object for each entry. The input schema is built dynamically from the params list. Adding a new tool to the config automatically makes it appear in the next tool/list response with zero code changes. The dispatcher is clean because all the routing logic lives in the tool map. We look up the tool name, retrieve the API and tool configs, and pass everything to call API. If the tool name is not in the map, we raise immediately. HTTP errors from the API are caught and converted to descriptive error messages. The entire dispatcher is under 15 lines regardless of how many APIs and tools are in the config. The Claude desktop config is identical to every other server. Each API token is passed through the environment object. If the config defines 3 APIs with 3 separate tokens, we pass all 3 environment variables here. Claude now has access to every tool defined across all APIs in the config. Ask it to get the details of a GitHub repository and it calls getRepo, reads the JSON response, and summarizes the repository. You now have a generic API wrapper that turns a config file into a full set of MCP tools. Adding a new API is a config change, not a code change. In the next episode, we tackle authentication and security in depth, API key rotation, OAuth tokens, scoped permissions, and protecting sensitive tools from being called without explicit user approval. Subscribe so you do not miss it. See you in the next one.